Mr. Maldonado here. As you can see, I'm not in class today. I am at a training today for PBIS, which is awesome. I did leave a great activity for y'all to do online, so I hope you really enjoy it today. Alright, so as you know, yesterday we started talking about potential and kinetic energy. You've also been doing that vocabulary homework assignment by watching that YouTube video that I put online with potential and kinetic energy. So I'm pretty sure you're doing awesome on that homework assignment. So today we're going to continue looking at potential and kinetic energy, this time with an online simulation. So what you're going to need for this is you're going to need your computer. You're also going to need the handout that I'm showing you right now here on this screen. So this one should be in your journal. If you do not have your journal open to this page yet, please go ahead and pause this video, open it to there, and then continue playing the video. Alright, so as you can see on this handout, in the top left hand corner, you have an image as to what your screen will look like. And you have a skater at position 1 at the top, position 2 halfway between the top and the bottom, and position 3 on the very bottom. You also have 6 questions that you need to answer. Now, today's simulation should be enjoyable. I do want to let you know that you will have time to kind of play around with it on your own and test different things on there and see how it really works out. But before that, you do need to make sure that you answer these 6 questions. Alright, so in a little bit, you're going to pause the video. You're going to go to the description section of this YouTube video, and what you're going to do is you're going to click on the link in the description, and it's going to take you to the site that I need you to be on. So go ahead and pause the video, click on the description, and then continue playing the video. Alright, so if you've clicked on that link, this is the screen that you should see on your computer screen. It says Energy Skate Park Basics, and there's 3 sections to it: Intro, Friction, and Playground. So the one that you need is already highlighted and enlarged, which is Intro. So go ahead and click on that. Alright, when you click on that screen, this is what you should see. So we need to make sure we click a few things first to make sure that you're able to answer these questions correctly. Start by looking at the very bottom of your screen in the brown section. In this brown section, you have a section here that says slow motion and normal. Right now, normal is the one that's clicked on. I need you to click on slow motion. Great job. Alright, then right next to that you see a pause button here that's highlighted in a blue color. I need you to click on that and it'll turn into a play button. So great job with that, guys. Alright, next thing, in the top right hand side over here you have a box that says pie chart, bar graph, grid, speed, and math. I need you to click on the one that says bar graph. Alright, so now on the left side you have this graph that's opened up. It doesn't have any bars on there yet, but right now we'll start to see a few. You're going to focus on kinetic, potential, and total. So the last thing you need to do here on the screen, you need to click on the skater and drag him all the way up to the top of the ramp. Now you should see that your bar graph has some bars on there. The total bar will always stay the same. It's at that level because it's at 100%. Potential is the only other one that's highlighted right now there also. So, go back to your questions. Let's look at the first question, because we're going to answer this one together. How much potential energy does the skater have at the top or position 1 at the ramp? So in the picture you have here on your handout, you see where position 1 is. That's exactly what we have on our actual computer screen. So, we want to know how much potential energy they have there. So look at potential energy. Do we have any kinetic with it? No, it's only potential. How much should I say this total bar totaled up to again? Great job. This total bar is 100%. So right now, potential is also at 100%. So that would be our answer for this one right here. Alright, so how much potential energy does the skater have at the top or position 1 of the ramp? 100%. So when going back, when going back, guys, to your computer screen, if the bar is halfway of total, it's at 50%. If it's 3/4 of the way, you should know already with your fractions, 3/4 equals 75%. If it's 1/4 of the way, it's 25%. If it's all the way at the bottom, there's nothing there at all, it's at 0%. So if I press play on this, the skater starts to move up and down the ramp, and kinetic and potential energy in the bar graph also starts to change. So your job is to pause exactly where it is that you need to pause according to whatever the question is asking you. Alright? Are there any questions on this? Because if there are, can't be there to answer them, so you need to ask each other, help each other out, ask the substitute, Once you're done, then you can go ahead and click on pie chart, grid, speed, change the mass to small, large, change to an L shape, change to a W shape, whatever it is that you want to look at here. Of course, there is something you have to do with it. Whatever you play around with, you do need to give me a half-page summary as to what you noticed as you changed the mass, or as you started looking at the speed, or what was the difference between the skater on the U-shaped ramp and the L-shaped ramp. That's exactly what it is that you're going to be looking at here. Alright, so go ahead guys, I hope you have a really great day, and I will see you tomorrow. Don't forget to finish your homework.